Hello and welcome to Cotenpal Analytics. Today is day one of manufacturing analytics. As all of you know, we do analytics using Titanic or sales dataset. But what real industries want? Real industries want real-time datasets. So today we will learn about descriptive analytics and answer this one question. What actually happens inside the industry? If you are making a data science portfolio or you are preparing for any job, then this video is for you. What actually is descriptive analytics? Descriptive analytics answers these few questions. How much did we produce? How much time did it take? How many defects occurred? And which machines and shifts perform better? Think of descriptive analytics as a medical report. It does not prescribe you medicine, but it tells you what actually is wrong. Now, let's start the data analytics process. So, let's have a dataset overview. Okay. So, before moving on to dataset overview, first of all, we need to import pandas library. Then we will set the display max columns as none so that every column will be displayed in the data frame. So first of all, df equals to pd.read csv and the manufacturing dataset csv file. Then df.head will give you first 5 rows of the dataset. And we have the features like production ID, date, product type, machine ID, shift, units produced, defects, production time hours, material cost per unit, labor cost per hour, energy consumption per kilowatt hour, operator count, maintenance hours, downtime hours, production volume cubic meters, scrap rate, rework hours, quality checks failed, average temperature in degrees Celsius, and average humidity percentage. What this dataset represents. Let's have a quick sanity check. Each row, one production run, shift level record, and capturing. We have operational variables, product type, machine ID, shift, units produced, production time in hours, operational count, maintenance hours, and downtime hours. Cost and efficiency variables. Material cost per unit, labor cost per hour, energy consumption in kilowatt hour, production volume in cubic meters, and there are quality variables like defects, scrap rate, rework hours, quality checks failed, and we have environmental variables as well. Average temperature in degrees Celsius and average humidity in percentage. This is an excellent data for productivity analysis, cost optimization, defect and scrap root cause analysis, machine or shift performance comparison. Let's have a production level output analysis. First of all, we need to show what are actually the columns available. Like df.columns, it will show you all the columns what is present in the data frame. Now we have a total units produced as a variable and it will store units produced and its sum. So total units produced, you can say 3,75,113. Then we have average units produced per run. Then average per run we can define be as df units produced dot mean. It will give you the average per run, which is 125.037 up to 3 decimal places. We have also highest output by product type, df dot group by product type, units produced dot sum. You can sort the values in descending order as well. And if you will cast into the frame, this will give you the result as this. This will be the result. You can say that automotive is the highest unit produced, that is 82,557. Then average production time per run in hours. Average production time will be average product. DF will name the data frame and its columns and set it to mean value. This will give average production time per run, which is 12.57. Then we have shift wise performance. Similarly, we will be grouping into shift and units produced as the sum. This will give you the shift wise performance analysis. Then machine ID, how many machines are there inside this data frame? There are actually 20 machines are there. For counting these 20, you will be using n unique values as your function. Then if you will use group by and machine ID with units produced, this will be your output. which one is producing more, which machine is producing more units. That is machine number one, that is 22,619. After that, we will go to cost analysis. In the cost analysis, we will be having material cost versus the product. We will be using the group by function product type with the material cost per unit. Then after we will this will plot a bar graph like this. This actually gives furniture as the highest number of average material cost per unit being used in the furniture. Then for labor and energy cost, we will be using shift as our grouping variable and labor cost per hour and energy consumption in the display. So this is your output here. Group by product type defects. It will show you the defects. What are actually the defects in the average defects in the all the product types? It is most of them are similar to each other. Then for scrap percentage, we can calculate from the scrap column, that is into 100. It will give you the scrap percentage. Average scrap rate, you can find it as dot mean value, and average scrap is 3.0255. Here's something most beginners ignore: temperature and humidity. Humidity varies from 38% to 59%. Environmental factors often cause material expansion, surface defects, rework. Sometimes the machine is blamed, but real culprit is the environment. So this is all about your descriptive analytics from the manufacturing background. If you do like the video, then subscribe and like our channel. Thank you.